So how does it work to apply some of these theories? So the first thing we're going to look at is how do we apply Cpctc? So a couple of questions here. First one, give the congruent statement, number one, and the reason, there's number two, and number three, use Cpctc to identify the remaining parts. So let's break this down. So the first thing is I have to look at, and I like to look at the reason. And what I'm given here and what I see is that I know this side and this side. I know this side and this side. I know this side and this side. The angle is there, but they're different, but it doesn't matter because I know three sides are congruent. So these triangles are going to be congruent by side, side, side. That's the reason. Congruency statement is where we say triangle, and just name the first one, ABC is congruent to. Now A is between the 1 and the 3 hash marks. That corresponds to R, to triangle R. B, I went down the single hash side. I go down the single hash side, I go to I. And then I go down the double hash side to C, down the double hash side to T. This must be this order. Now, you could start with triangle BCA, congruent to triangle ITR. That order can change, but no matter what you do, B and I have to be in corresponding positions in the order. So this is the congruency statement. Here's my reason, side, 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 because I knew three pieces were congruent. Now, part 3, Cpctc. Remember what that means. Corresponding parts. So you have to know the triangles are congruent. Then you get corresponding triangles are congruent, those corresponding parts. So I used the three sides to prove congruency. So now here I get 3 angles. So whatever you use, if you use side angle side, that's 2 sides and an angle to prove congruency, then you get 1 side and 2 angles. You get the remaining parts. It's like a buy 3, get 3 free. So by Cpctc, I know that angle A is congruent to angle R. I know angle B is congruent to angle I, and I know that angle C is congruent to angle T. So if we look at number 2, use the picture below to answer the following questions. So I have 2 angles marked. What do I need to prove them congruent by angle, side, angle? Now remember, angle, side, angle, I need the side in between the angles. So I would need to know that CB is congruent. C has 2 hash marks. F has 2 hash marks to FE. To use angle, side, angle, because I need that side that's in between the angles. It must be in this order, or you could say BC is congruent to EF. But again, wherever B and E line up, they have to be in the same position in my list. Now, if I want to prove this by angle, angle, side, remember that is 2 angles and the non-included side. So I could use this side and this side. I could say that D, couldn't read there, DF is congruent to CA, and that would prove the triangle is congruent by angle, angle, side. Or I could go with this non-included, and I could say that AB is congruent to DE. So different sides would be used to prove use different theorems to prove congruency. Okay, so the naming really matters, and you have to pay attention to the relationship between the sides and the angles. So are these 2 congruent? I look, I've got two angles and a non-included side. Do I have corresponding? I've got two angles, we're good, and I have a non-included side. But look at those sides. Those sides, if I tried to slide this triangle over and match it up, those are not corresponding sides. So these are not congruent, even though it initially looks like angle, angle, side. It's the wrong side. It doesn't match up. I would need this side to match up with this side. Okay, so they're not congruent because sides don't correspond. And remember, geometry is all about explaining your thinking. It's all about explaining your thinking. So let's look at the next example. So I have two angles, or I've got an angle and a side here. So what information do I need to prove by angle, side, angle? Remember, this is the side is in between. So if I want the side in between, angle, side, angle, angle, side, angle, I would have to know that angle T is congruent to angle X to use this theorem. But if I want angle, angle, side, remember this side is outside, not between the angles, I would have to know that W and Z, because then I would have angle, angle, side, angle, angle, side, the non-included side. So I would have to know that angle W is congruent to angle Z. Now, if I want to then prove it by side, angle, side, remember now my angle has to be between, and I knew this one and this angle, I have to know that side. This one, this angle, and this side. And so that would be, I wrote on my picture, I can't read it. My only option there is I would have to know that VW is congruent, order matters here, V corresponds to X, to XZ. So this is a great way to look at how a different side, the triangles are still congruent. All three ways the triangles are congruent, but it would be a different reason each time based on the given information. So let's do a quick little application problem. In the following diagram, Midtown is exactly halfway between Uptown and Downtown. What is the distance between Downtown and Lower East Side? How do you know? Write a few sentences to convince your reader. So this given right here, Midtown is exactly halfway between Uptown and Downtown. So that means those are equal. So that means this is 2.1. And when I look at this picture from way back in Unit 1, I know that this angle and this angle are equal by vertical angles. And 90-degree angles are equal because 90 is equal 90. And when I look at that, I have an angle congruent to an angle, a side congruent to a side, and two more angles congruent. And so that means these triangles are going to be congruent by angle, side, angle. And if they're congruent by angle, side, angle, then I know by corresponding parts of congruent triangles that this distance right here has to be the same as that distance because those sides correspond. So I know from downtown to Lower East Side is 1.5 kilometers. So that's how we would use a proof. Our Cpctc, by Cpctc, the upper to upper has to equal downtown to lower. We're not exactly using coordinates, but my explanation. So then I know that side would be the same as this side.